Hi everyone, my name is Avani Reddy and I'm a program manager on the AI and Ink team. This is Ibo's son and he's a developer on the team. And we're here today to talk to you about how you can create richer experiences in your applications by taking advantage of our AI-infused ink. Now, I know what you're really here today to see is some coding. So I'll hand off to Ibo to show you exactly how you can create an inking app using ink.
Good morning, everyone. Good morning, everyone.
Good morning.
So let's warm up with some coding. It's so glad to see all of you here. So I'm very looking forward to see feedbacks from you. The app I'm going to create is for me to collect feedbacks from you. Instead of crafting UI in Visual Studio, I like to just draw it. The tool I'm going to use, called Ink2Code, is from our Garage Intern project. Use our ink analysis API, and let me show you. First, I'm going to draw a rectangle. Ink2Code understands I'm defining the app boundary. And depends on it's tall or wide, it will know that I'm going to have a horizontal or landscape view. This is particularly useful when it is on phone. So next, I'm going to draw a small rectangle. And Ink2Code knows that I'm going to have an input field here. Also, I want to have the placeholder text. So you know that I want you to put your name here. Same thing for email. Now I'm going to have a larger one for comments. I can move a little bit upwards. So I have the room for the button. Now, instead of writing text in there, I'll draw a circle. So Ink2Code understands that I'm going to have a button here. All right? Now I just define my UI and I export using my Visual Studio project. Upon desktop, save. Now I have just to create a new UWP application. As you can see, the UI is empty. I will open the UI just created, and let me drag in here. So I'm going to copy paste all the UI I have here and replace the whole thing. So as you can see that the Visual Studio automatically pick up the UI I just created. To save the time waiting for building, I have it opened here. So for a simple application with ink, I already saved a lot of time to crafting in Visual Studio. But I want to do something more. Because as I promised, I'm going to create an inking app with ink. Now with the ink part is already like show, I want to show you that's an inking app. So how can I make you to directly write in the input field? You might think, okay, so now I have to create an ink canvas, stack on top of the ink input field. And then on stroke collected, I feature recognizer and got text, replace. And then, wow, this sounds a lot of work. And also, what about correction? Can I support gesture? And all kinds of stuff. How about candidates? Okay, wow, too much. Now, here's the good news. We did all this heavy lifting work for you for free. All you need to do is go to the settings, go to the pen setting page. Now, toggle right directly to text field. And let's get back to the app. Now you rest your pen and you can see you can already write it in here. That's the inking app I'm going to introduce to you. So for the name, I can write here. As you can see, that's a candidate panel I just mentioned. And an email, I can also put it here. Just to mark something up. And if that's not right, I can always strike through to correct that. So Avani will walk you through the complete gesture sets in the later slides. And the cutoff is due to the resolution for our presentation, so never mind. And also, I want to show you that we also support a multi-line. So the first two are single line, and as you can see that we also support multi-line scenario here. One thing to point out is that for better accuracy, do remember always put input scope into each field. Let me show you why it matters. So here I have a side-by-side comparison view. And for the number, this one does not set any input scope into it. If I write a number, it'll basically recognize, just treat as normal text. But if I set input scope and number, so it will always remember, let me do it again. I literally intentionally leave some room here. As you can see, we understand you're going to put one number here, and we will take care of that. Also for email, the same thing. So see the idea. And now, if I set email input scope, so as you can see, it's much more accurate now. And also, we provide API for you. For whatever reason, if you want to enable or disable embedded inking control in your application, you can also do that. So here I have it on, but you can toggle it off. Now, whenever you do that, it just becomes an ordinary control. And let me show you how to do that. So first, I'm going to show you the input scope. I will use email as example. And sorry for the IntelliSense, just to play funny on this project. But you can see that here's a way that you can specify input scope, telephone number, email, and number. And also for toggle embedded inline control, inking control, you can set is handwriting view enabled to true and false to enable or disable. All right? Okay, so we just warm up with some coding. And I will switch back to Avani to walk you through our inking platform. Thank you, guys.
Thanks, Ibo, for giving us that great example of how you can build an inking app using a typical scenario that you may encounter, form flows. Now, I want to take a step back and talk to you about why you should incorporate pen and inking features in your applications. When you think about the pen and ink, what do you think about? I think about my 8-year-old cousins who want to be fighter pilots when they grow up, and the adorable drawings they make for me showing them doing that. I think about my sister and the amazing detail-oriented notes that she draws when studying for her organic chemistry tests. I think about my civil engineering friends who work in construction and the plans that they mark up to show others where work needs to be done. The pen is a tool for creativity and expressiveness. I also believe it's a tool for productivity, especially when fused with AI. All of the things you see here are things that the mouse and keyboard will never do as well as a pen, because you lose something when you type that. We have compelling data that tells us that pen and ink are important to our consumers. We see that 212 million adults on a daily basis are using the pen. And think about the potential growth for digital pens in this space. The pen is third in purchase intent, higher than the switch to SSD, which, as many of you know, was a primary factor in choosing a device. we see that we have 10 times more pen-enabled devices in our ecosystem than iOS or Android. And our NPS score, which tells us how likely someone is to recommend our products, is 8 points higher for pen-attached systems. And this data collectively tells you that we're putting more pens in the hands of our consumers to increase the reach of your inking apps. We see that more and more inking apps are coming to our Windows Store, and of those apps, they are the top revenue-producing apps in the store. So, with all of this data presented to you, why don't you consider adding pen and inking capabilities to your applications? The Windows Ink platform makes it easy to add ink to your app. To start, you just need a few lines of code. It's that simple. And we provide a natural experience. Our pencil brush is texturized just like a real pencil and responds to tilt and pressure the same way a pencil does in real life. No matter if you're a UWP or Win32 developer, you can still take advantage of our powerful inking APIs. We know that not everyone renders their UI with XAML. Office's Win32 application still renders their ink with DirectInk. With our Windows Ink devices, we have the world's fastest low-latency ink. And with all the experiences that we offer you, we make sure that AI is fused every step of the way via classification, layout analysis, and recognition. Now let's dive into the Windows Ink platform and take a look at it from the top down. When we look at the top level, we have our XAML controls. And with just 2 lines of code, you get a XAML ink canvas to lay ink down in your application and an ink toolbar that allows you to select brush options from. As of the latest release, we even have an embedded inline handwriting experience that Ibo showed you at the beginning of this presentation. Now, as we look at the lower levels of the stack, we offer you powerful inking APIs, as well as ink analysis APIs. And now, we even have a cloud service available for our ink analysis APIs. And at the lowest level here, we also have a great pen and hardware ecosystem that supports all of this, though we won't touch too much on that today. Now, let's take a look at our XAML controls, the easy-to-implement UI wrapper around our APIs. Now, these really provide for the majority of your use cases. If you just want to add ink to your application and not worry about the UI, this is the best way to do it. With just 2 lines of code that you see here, you get the ink canvas, which allows your users to draw in your applications with ink and render that ink, and an ink toolbar to bind to the ink canvas and allowing you to select different brush options and color options. And again, all of this for just those 2 lines of code that you see on the screen. One of the primary things in your workflow is entering text, which has been proven difficult with the pen in the past. So we thought, let's take a look at these XAML controls that we have. We have the general text box that allows you to enter simple text. We have the rich edit box that allows you rich formatting with the text you're entering, and the auto suggest box that populates suggestions as you're typing. How can we make the pen a primary input factor across all of these different XAML controls? Our solution was the embedded handwriting experience, offered for free in all of those XAML text boxes you just saw, and built right into the framework. This allows you to continue naturally using your pen, rather than having to switch to the soft keyboard. We even have a multi-line experience, as Ibo was showing you, so you can continue writing just as you would on a sheet of paper. We have gestures for the most natural editing experience that you can see here, so you can use them the same way across the entire Windows ecosystem. All of this is offered to you for free, and it's an entire experience for your app to consume. We have powerful inking APIs that you can use in your app, regardless of if you're a Win32 or UWP developer. Now, right out of the box, we offer you 3 different brushes: our ballpoint pen, a highlighter, and a pencil brush. And Windows Ink makes rendering all of these brushes fast and fluid. You can even create custom variations of these brushes by changing the tip shape and rotation to build whatever you'd like. And all of these are offered to you completely for free, and you can implement whatever type of UI you want on top of them. As of the latest release, our ink is faster than ever. We first pioneered this with the Surface Pro 2017, and now with GPU preemption, Windows no longer has to wait for the next scan out on the screen to get ink. And we're not making your users go out and buy the latest and greatest in technology to get this. As long as you have the correct compatible graphics hardware, you get this already, which means your users of your inking apps are going to have a better experience in Windows in those inking apps. And we're looking for even better performance in future releases. With the Microsoft Pen program, we're putting millions of pens in the hands of users to increase the reach of your inking apps. And any pen that speaks the Microsoft Pen protocol can interop with different devices. Now, I've just touched on how easy it is to add ink to your application so you can capture your users' thoughts. But we strive to go beyond that. Think about when you're in a meeting and you're at a whiteboard. When you're drawing on the whiteboard, what do you want to do at the end of the meeting? You want to transcribe those notes and send them out to the people in the room. When you start designing something, what process do you typically take? You initially sketch something out, and then you iterate on top of it to make a finalized version of that product. This is where SmartInk comes in. It's our set of AI-infused APIs that truly embrace the digital nature of ink and allow you to move beyond what traditional pen and paper allow. SmartInk is about moving from ideation to polished content seamlessly. Now, we showed you Ink to Code at the beginning of this presentation. And what's great about this is our garage interns were able to pick up our ink analysis building blocks and build Ink to Code over the course of just one summer. And we showed you a couple of the feature functionalities at the beginning here, but you can see the full breadth of what you can do. You can create image and text placeholders, as well as buttons, and use natural gestures that mimic the gestures that real designers use when drawing in real life. All of this you're able to realign in whatever position you want to build these wireframes. And when you're done here, you can even take all of this and export it to Visual Studio. And once you're there, you can continue further editing for better experiences. Like Ibo was showing us, you're able to add input scopes to more clarify what you want to input. And we love this video because it showcases a couple of design principles we talked about earlier. It capitalizes on the natural interactions of users using the pen, and it showcases unique, differentiated experiences that are powered by our platform. When people think of ink analysis, you typically think of recognition. But classification is where the actual structuring begins to help. When you're writing on a sheet of paper, it's not a structured surface. You're just writing down what you're thinking. The core of what ink analysis offers is the ability to understand the ink that's on the screen. Writing is inherently messy. We see that with ink analysis, you can use our APIs to determine which strokes are composing writing regions and which strokes are composing drawing regions. And the ones that compose writing regions are those that compose words and characters. Now let's take a look at this example here. In just one step, we've understood that every ink stroke on this screen belongs to a writing region, or a word or character, and that there are no drawing regions on this screen. But we can go even further to collect more metadata. With the layout analysis, you're able to create a tree-like structure and understand the children and parent nodes of your ink on the screen. Now, let's keep looking at this example here. We're able to see that there are 2 paragraph items within that writing region. And of those paragraph items, we have 3 line items. And we can even tell that the bottom 2 are list items because there are bullets in front of them. Within each of these, we can identify each word. And we can even identify the bullets as well. And once you have your data broken down into these manageable units, you can create really powerful features, such as an app where you can tap once to select the word, tap twice to select the parent node, a line, and tap 3 times to select a paragraph. You can even enable very complex scenarios, such as determining annotative text within a block of text, or distinguishing ordered lists. All of this data is available to you if you use our ink analysis APIs. Now, once we've finished classifying your data, we then recognize what your ink actually is. We determine what your word actually says, or what shape we've actually recognized. So say you're making an app where, in any case, you're identifying the words that your users are writing. We offer you alternates to the text of what has been recognized, so you can present your users with multiple options before converting their ink. We can even recognize slanted handwriting. Now, of all the shapes that users draw, we see that these are the ones that are drawn the most, and you can recognize all of these in your apps. The bonus shape is an ink drawing that we can identify as a general drawing. Now, with that overview, I want to hand off to Ibo to show you exactly how you can put ink analysis in your apps. Still.
All right. Sorry. Thanks, Avani. That's a beautiful tree. So why is that important that we know that document tree? Is that now we can operate ink document at any semantic level. Word, line, the whole list, paragraph, so on and so forth, depending on scenario. On the top, it's the familiar ribbon UI. We can see that on text, there's so many operations we can do on that. Below is my hobby project called Ink Editor. I want to show you with ink analysis APIs, we can do the same on ink. All right. So let me load some notes. Well, it's a little bit sloppy. I'm still working on it. Let's see. Okay, so as you can see that the list is not horizontal. They're not aligned. And the title is like how to take notes. But who don't know how to notes? We want to show people how to take good notes. So title is actually not completed. So let me do that. Selection is always the entry point of all the editings. So I can select, and as Avani mentioned earlier, I can table select to expand the selection to the line. For the list, I can expand the selection to the whole list as well. I will move around. So because of the resolution, the entire list is not showed here. Let me show you in here. And also the last one I mentioned is color code. But there's no color coding at all. So I want to do all of them in my editing. So first of all, I want to make some room so I can complete. Okay, let me start with writing good notes. Well, the style is off with its neighbors. Never mind. We can, So, based on the resolution, and you can see now I have a word recognized. I want to be red. And also, I think it's not thick enough. The size is also off. Okay, put it back. So now it seems that I complete the title. I want to do something more. This is not horizontal. Let me rotate one by one. I can drag and drop as well. And I have to select all of them. And I can play around with alignments. So I can align with other ways, like align to the right. Now, I still feel align to the left seems better. So put here, keywords as well. I want it bolded, or like put them to blue. And for this, I felt that, because there's one list item at the end due to the resolution, it's not shown here. I feel that it's not vertically aligned. So let me adjust the space between that. As you can see, now I can handle the ink document just like I'm operating on the text document. Let me show you the code, how I achieved the operation so far. First of all, document tree. We need the document tree to know what this ink document is really about. To do that, I have two options. One is that I analyze all at once, or I can update Ink Analyzer and analyze incrementally. Here, the most cases, I'll update Ink Analyzer and analyze incrementally and cover them later. Now, once I have this document tree and user tab on Ink Canvas, it's really easy that because I understand the tree and the bounding rack of each component, now I can start with the leaf because I want to start with the smallest scope. So the ink word, ink bullet, and also the ink drawing are at the leaf as shown by Avani on the tree. So I will start that, and then I'm going to expand the selection. That's also easy because I just traverse to the parent. I'm done. As you can see here, I will just traverse to the parent. Here also, you can traverse based on your application logic. So here, as I show here, if is a list item, if the children only has one line, it looks visually just like you're selecting a line. So I will skip one level and select the parent, the whole list at once. Now for alignments, here's another way you can traverse through the children. Well, actually the same way. So we iterate each child, which in this case is either the line in the paragraph or the paragraph in the writing region, because we limit our alignment into this unit as called from the function align paragraph or writing region, and we only apply it to direct children. So how we do that? So based on alignment references, left, center, or right, we calculate the alignment references. And now we know the bounding rack of each children. With these references, we can transform the ink. After that, do remember, you need to update ink in Ink Analyzer so we have the latest ink in the view. So the rotation, Just as Avani pointed out in earlier slides, we understand the rotated bounding rack. So we know that how slanted is your content. And we can calculate the rotated angle. And now we can transform the ink to horizontal. Again, don't forget to update the ink in Ink Analyzer. All right, so I already showed you that I can manually do this one by one, but you can see the pattern, how I convert a sloppy notes to a tidy one. I horizontalize each line. I adjust the alignments. I adjust vertically the space between them, and also horizontal spaces as well. So how about just put them together, optimize them with one click? Sure, we can do that. Let's show you. Let's load the original one, the sloppy version. And I will not add the good for this time, but I put everything here. Now you can see I can tedify the whole notes with one click. And let's try something else. So this is a math note. As you can see, it's slanted and stacked together. And it makes much cleaner. Also, had this one we showed before, and this one has some shapes. Again, we can, with one click, to tedify the slides. The last one I want to show you, not only just one language. We have some mixed language here. That's like a Chinese and English mixed together. Ink Analyzer, understand that. As you can see. Thanks. So let me show you how I achieve that. So first, we will have this like document tree. And then I'm going to have all the structures on the document tree and save for later use. As you can see that I will first horizontal the lines, align all the paragraphs, align all the lines, adjust spaces, and now, after everything is done, the ink document is totally different with previous one. So I analyze again to update the document tree. You can put your customized Tedify approach in here to put your own Tedify. So let's get back to the slides. Slide one.
Great.
Yeah, okay, let me. So just to recap on some key concepts and tips for Ink Analyzer. So first, I showed you stateful or incremental analysis is the one I use. But if in your application, all the analysis is independent with previous ink session, then you can choose. I will just don't consider the previous analysis at all. I will always get the new strokes all at once, feed to Ink Analyzer, clear the previous notes, and then analyze cleanly. Or just as I showed you, that I always update Ink Analyzer. When I collected something, I add to Ink Analyzer. If I erase something, I remove from Ink Analyzer. And also, whenever I transform some ink, I update Ink Analyzer with replace data for stroke as well. One thing to point out is that though the ink content is updated in Analyzer, the node property will not update it immediately until the next analysis. So there are two ways to extract information from document tree. One is that through Find Nodes API. So if you have a particular node type you want to search, then you can use this API. Or you just traverse the document tree with child and parent. Stroke ID is the important concept you want to keep in mind, that it uniquely identifies an ink stroke in ink canvas and also uniquely identify the stroke in Ink Analyzer. So once you decided you convert ink and you want to remove from ink canvas, do remember you use that to remove from stroke container with stroke ID get from the node. The last one I didn't cover in my demo is that if your application has some context, for example, in embedded inking control I showcased earlier, all the content must be writing. Or in your application, you have some mode switch, only allow user to have shape as input. You can use this information and set stroke data kind, limit to writing or drawing. That have two benefits. One is some of our engine is bypassed, so the analysis is more lightweight. The second is that now you achieve better accuracy. But if user decide to mess up with your application, you will still guarantee you have the outcome as writing or drawing you specified earlier. All right, so hopefully you get the key points of using Ink Analysis API. I will switch back to Avani to walk you through what's in the future.
Great. Thanks, Ivo, for that great example of a scenario where you may want to keep ink as ink, but continue editing it. Now, I want to talk to you about some new and exciting offerings that we'll give you a sneak peek of today. So, how do we take SmartInk for Windows and build cross-platform apps? We have a brand new cloud service for our Ink Analysis APIs, already being tested and proven by one of our biggest partners, Office. Now, I want to show you exactly how powerful this implementation in Office is. So, when you're a student, the best way to take notes is by drawing them out. It allows you to better understand whatever your teacher is telling you. And say you get back home and your teacher says, I want you to write a paper on the notes that you took in class today. And you have this phase change diagram that's been presented to you. Now, what's the fastest way that you can get this unpolished version into a polished, nice one, pretty enough for your paper? Let me show you how Office has done this with our Ink Analysis cloud service. If we tap on these here, we see in the top right-hand corner, an Object UI now appears. And if you tap on this Object UI, you see that there's an option to convert your ink to shapes. And just like that, we've easily cleaned up those two shapes. And the great thing about it is, if you tap again and you want to go back to the ink that you previously had, you're also able to do that. Now let's take a look at the words here. I selected with the barrel button, I held down on it, and I selected that text there. And we see that the same Object UI now appears. We can tap on it, and we now have an additional option to convert to text. Now let's do that. As you can see, in just one simple step, we were able to convert that to text quickly and easily. And now it's just a text box, and you can treat your text the same way, bold it, change the fonts, etc. So if you're a student and you wanted to do that quickly, you now have a very fast and easy way to do it using our cloud service. So just to review, why would you want to use our cloud service versus the client APIs? To start, we know that you may be building cross-platform applications, but you don't want to have different recognition logic for each platform. Our cloud service allows you a way to consolidate your recognition logic cross-platforms. And then you also get all the benefits of the Microsoft Cloud. You can compute larger models in the cloud. You get faster updates because we're constantly updating our models there. And you get the personalization of the Microsoft Cloud and Graph. And Right now, we have this available as a cognitive service lab in private preview. If you go to the Cognitive Services website and look up Project Ink Analysis, you're able to find that there now. And because this is in private preview, we have only been working with internal partners, but we want you to be the first external partners to partner with us on this co-engineering project. So if you want to consume our cloud ink analysis service, please reach out to us. And here's the spot where you can reach out to us. We have our alias here, windowsinc@microsoft.com. Please send us any questions that you have there. We also have all the references for some of the things we talked about during this presentation. And follow us on Twitter for the latest and greatest updates from the Ink team. Thanks.
Thank you.
So if you have any questions, we'll take them now. And we have 2 microphones on either side if you want to come up.
Hi.
Hello.
So I think the custom shapes the shapes API is really neat that you can just use this and get a list of what potential shapes there are. Is there any plan to open that up or expand that or allow developers to write their own, like what kind of custom shapes they want besides the ones that you've built into the library?
Yeah, for the roadmap question, I leave to my lead, Shen.
Yeah, so if you were in our sneak peek the other day, actually in our roadmap, we're planning to have a extensible plugin models so that we're able to provide a training service that you can train your own customized shape and use your own customized model.
Okay.
I enjoyed the presentation. It was really good to see these things come off, especially in Office. So with the cloud service, if you're trying to use it with Office, let's say, do you have to be online and use those APIs that way?
You do have to be online to have the cloud service enabled.
I see. Is there any plans to sort of run it on the local edge later on, maybe with advanced maybe systems with GPUs and such?
Yeah, I'll leave to Zhao to answer that.
Yeah, it's a little bit hard.
Yeah, hi, my name is Xiao. I'm the dev manager of the team. So actually, everything presented today, they all work on the client edge side. Okay, we just took as one of the slides I want to show, we took the edge side of the engine and moved to the cloud.
So my question is, can you bring that down onto the edge?
Yeah, so the PowerPoint scenario that only works on the cloud side because it's tied to PowerPoint's designer service.
Mm-hmm.
But everything else demoed like Yibo's demo app, all the APIs, these are available in the UWP Windows Ink Analysis APIs. Right. So all the shape recognition, handwriting recognition, they work on the client side.
Okay, all right, thanks.
Hi. So actually, I understand this is for the Windows applications normally. So when you have introduced this cloud services, is it possible that you can incorporate this one with web applications?
Yeah, actually, the cloud service, you can call it from web applications and websites. And actually, in one of the sneak preview, Kyle, our program manager, actually shared the data format, the input to those are just REST APIs. And we take ink data as JSON, and the output of the tree, they are also a JSON format. So yes, the service would work for website and web applications.
So how you take the stocks? Is it actually basically like, you know, what kind of input do you take? It's based on points or, you know?
Yeah, the input is actually very simple. When you draw, say, a line on your screen, And whether this is on iOS, Android, or like a website or Windows, you get X, Y positions of each point on the screen. So those are not images; those are just array of X, Y points.
Yeah. So you need just those points. You need to, we need to send only those points, right?
That's right.
To the REST API.
That's right.
Okay, thanks.
Mhm. You're welcome.
Great. Well, if you have any questions that come up later in the day, or things that you may think of after build, you can always email us at the Windows Inc. alias with your questions. We'll always be there to answer those. We will also be at our booth later today. We're under Client and Web and near the Fluent Design. So come by, stop by and see us. We have a cloud service demo there available as well that we can show you. So if you're interested in that, please stop by. Thanks again.
Thank you, guys.